Hello everyone, Darren from DrayTek Australia and New Zealand. Back in December 2023, we ran a webinar where we discussed how to improve network performance and security by using VLANs. VLAN stands for Virtual Local Area Network and is a way of segregating groups of devices or users to improve network security and performance. In today's session, I'll expand on what was covered in that webinar and focus on using VLANs in DrayTek VigorSwitches, which are often utilised in larger networks to cater for greater numbers of users and devices. I'll start by looking at why we need to use VLANs in a switch, then go on to looking at the different types of VLANs you can set up in a DrayTek VigorSwitch. We'll also look at the different interface VLAN modes and finish by looking at how to configure VLANs in DrayTek VigorSwitches. So why would you need or want VLANs in a switch? Isn't that the kind of thing that a router would normally handle? Well, in a large network, as shown in this diagram, much of the data traffic is between devices or servers on the local area network, with not a lot of traffic needing to go out to the internet. For example, IP cameras store videos to a local NVR, IP phones register to a PBX, and documents and files on PCs are stored on a local file server. So if we can keep all of that internal traffic out of the router, we can reduce the load on it and maybe even get away with a lower end router here. Utilising VLANs as well as Layer 2 Plus features in DrayTek VigorSwitches will improve network performance by making this possible. Let's now look at the different types of VLANs used in DrayTek VigorSwitches. The first type is port-based VLANs. Just like in DrayTek routers, each port on the switch is assigned a VLAN ID. Whatever is plugged into that port will be assigned to that VLAN. Also, as shown in this diagram, we can have a group of ports with the same VLAN ID. This can be used to separate out groups of users or devices from other groups. The next type of VLAN used in VigorSwitches is the 802.1q tag-based VLAN. This is where a single LAN cable from the router to the VigorSwitch provides the VLAN trunk connection. In the diagram here, we have 3 VLAN groups to cater for 3 different work groups or departments, and all through a single cable to the router. If you'd like more information on this, I'll leave a link to the previous webinar in the description below. Another VLAN type in DrayTek VigorSwitches is the voice and surveillance VLAN, which is available in Layer 2 VigorSwitches. These are VLANs that are specifically allocated for voice and surveillance traffic, which includes IP phones, IP cameras, and NVRs. Using these VLANs helps to simplify the network configuration by keeping the VigorSwitch ports in default trunk mode. Devices can be plugged into these ports with minimal configuration required in the switch. The VigorSwitch will automatically mark packets with QoS attributes and place devices in the correct VLAN. This helps to isolate VoIP and surveillance traffic from general data traffic, thereby improving data security. Data packets are prioritised using different Layer 2 802.1p class of service, that's COS priority, or DSCP, that's Differentiated Services Code Point priority, to improve VoIP quality. This diagram illustrates the process used to identify devices to be placed into the voice and surveillance VLAN. It uses the OUI, which is an abbreviation for Organisation Unique Identifier, and is based on the source MAC address of data packets. Here the data packet comes into the switch with a voice surveillance VLAN tag. The switch compares the source MAC address, that's the first 6 characters, with the pre-configured OUI. If a match is found, the data packet is classified as voice surveillance traffic and is remarked with a COS value and forwarded with high priority. More details on how to set this up is in application note 7577 in our knowledge base. Another way to identify the voice VLAN is with LLDP-MED, which is short for Link Layer Discovery Protocol Media Endpoint Discovery. Here the VigorSwitch will automatically identify voice traffic. It then sends that traffic, along with COS and DSCP discovered traffic, to neighbouring devices. When the devices receive these packets, they will add the voice VLAN tag and send the VoIP packets back with that tag. Another VLAN feature in Layer 2 VigorSwitches is MAC-based VLAN. This is a useful function when users need to move to different locations and still be a part of their department VLAN. With MAC-based VLAN, the VLAN assigned is determined by the source MAC address in the data packets. This will work regardless of which port on the switch the device is connected to or which SSID they are using in a Wi-Fi network. It'll also work through multiple switches. An example of where this will be useful is for employees who need to move around the building with their laptops and still need to access their LAN regardless of where they are connected. The last VLAN type we'll look at is protocol-based VLAN. This function is available in higher-end VigorSwitches. Different applications and services use different protocols. Protocol-based VLANs are used to segregate VLANs based on the Layer 2 protocol in the Layer 2 header in the data packet. This can be used to manage the network based on specific applications and services. The switch ports will need to be set up as hybrid ports. In Layer 2 and Layer 2 Plus VigorSwitches, there are 3 different group IDs corresponding to each frame, which can be selected. You can also create a custom group ID with the required protocol values. This table summarizes the VLAN types available in Layer 2 and Layer 2 Plus VigorSwitches, along with the pros and cons for each type, as well as suggested usage scenarios. Let me get out of the way and make that a bit larger for a moment so you can see that a bit clearer. Feel free to pause the video if you'd like a longer look. Let's now look at interface VLAN modes available in DrayTek VigorSwitches. In DrayTek VigorSwitches, you'll notice 4 different VLAN modes. These are Access Mode, which is used for VLAN unaware devices; Trunk Mode, which allows multiple VLANs to be sent over a single connection; Hybrid Mode, which is a combination of trunk and access mode settings; and Tunnel Mode, referred to as QNQ trunking. This mode is available in Layer 2 Plus switches and is mainly used by ISPs for MPLS networks. Access mode is used to connect general devices which are VLAN unaware. These devices, which can be PCs, printers, file servers and so on, do not add a VLAN tag to their data packets. As shown in this diagram, the switch using access mode can be connected to a router LAN port without any VLANs configured, and all devices connected to the switch can access the internet. Switch ports set up in access mode are known as access ports. For this, only the PVID needs to be configured. In the example here, the PVID is set to 20, so a device connected to this switch port will be able to communicate with any device on VLAN 20 within the switch. Trunk mode allows a single 802.1q VLAN trunk from a Vigor router to a VigorSwitch trunk port. The trunk port will allow multiple VLANs to be sent over a single connection. In the example shown here, the staff and guest VLANs from the Vigor router are being made available on both VigorSwitches as well as the access point. The trunk ports are used to interconnect the switches as well as the access point. When setting up trunk mode in the VigorSwitch, the steps include: select trunk mode for the required switch port, configure the PVID, that's for VLAN unaware devices, configure tag VLANs, that's accept tag packets only from member VLANs, keep egress packets to member VLANs tagged. Switch ports configured in hybrid mode are used to connect different types of devices with several identical VLANs. It's a combination of trunk and access mode settings. Devices can be either VLAN aware, such as routers, switches or access points, or VLAN unaware devices such as PCs, mobile phones and printers. Hybrid ports are used when the device connected to the switch port may access different VLANs based on different situations. For example, devices with different MAC addresses will be connected to this port and will access different VLANs, such as when using MAC-based VLAN, protocol-based VLAN, and voice VLAN. It's also used when the switch port has to egress packets to different untagged VLANs via one physical link. When setting up hybrid mode in a VigorSwitch, the steps are similar to trunk mode and include select hybrid mode for the required switch port, configure the PVID, that's for VLAN unaware devices, configure tag VLANs, that's accept tag packets only from member VLANs, and keep egress packets to member VLANs tagged. Here we have a comparison between trunk and hybrid modes. Moving on to tunnel mode, which is used to segregate different customers. It's mostly used by ISP networks and is typically used for multiple protocol label switching, that's MPLS, Layer 2 VPNs. Essentially, all the selected VLANs on one switch are sent to a remote switch over a trunk connection that encapsulates the VLANs inside another VLAN. This is sometimes referred to as QNQ trunking. In the diagram shown here, there are 4 VLANs, 400, 600, 1500 and 2400, which are encapsulated in the ISP trunk connection. When setting up tunnel mode in the VigorSwitch, the steps include: select tunnel mode for the required switch port, enter a PVID. All data packets entering the ISP network via a tunnel port are treated as untagged packets, that's tagged or untagged. Here we have a comparison of the uses for each of the VLAN modes. Pause the video here if you'd like to view it for longer. Let's now look at how to configure VLANs in DrayTek VigorSwitches. The configuration steps when setting up VLANs in VigorSwitches are: add VLANs, select tag or port based, assign VLAN membership for ports, assign a port as a trunk port, and configure ports. Let's go through the configuration steps for the example shown here, where we have 3 VLANs assigned to 3 groups of ports. Also, one of the switch ports will be an 802.1q trunk coming from the router. The router will also need to be configured with the appropriate VLANs, and one of its LAN ports will need to be set up as a trunk port. In this example, Gigabit Ethernet port 1 on the switch will be configured as the trunk port, and 3 VLANs will be assigned to groups of ports. We'll start by creating the VLANs. To do this, go to the Configuration VLAN Setup menu, then click on +Add VLAN. Then enter a VLAN ID of 100 and give it a name. Let's call this one Sales. Do the same for the other VLANs. We'll make this one VLAN 200 and we'll call it Administration. And same again. This one will be VLAN 300 and we'll call it Support. The next step is to configure the 802.1q trunk. To do this, go to the Configuration Port Setup menu. We'll make port 1 the trunk port, so select port GE1, GE stands for Gigabit Ethernet incidentally, and set VLAN mode as trunk. They all come up as trunk by default, but let's assume they're not, and click on the Edit button over here. VLAN mode at the top here, we can select from hybrid, trunk or access modes. We can leave the PVID as 1. Now for tag VLANs, select all the VLANs configured earlier. This will allow these VLANs to come through a single connection from the router. Next, we need to assign VLANs to each of the switch ports. These will be access mode. We'll make the first group ports 3 to 8, so select port GE3 to GE8, then click on Batch Edit, which allows us to edit them all at once. Enter the PVID of 100 and change the VLAN mode to access mode. Click OK to save. Now do the same for ports 9 to 16 and assign PVID of 200. Finally, same again for ports 17 to 24 and assign PVID 300. Okay, so now port 1 is our trunk port, which will connect to the router. Ports 3 to 8 are VLAN 100, our sales network, so anything plugged into those ports will become part of that. Ports 9 to 16, VLAN 200 is our admin network, and ports 17 to 24 for VLAN 300 is our support network. They'll all use the same internet connection, but they can't access devices in other networks unless we allow routing between them. Another method to create VLANs in a VigorSwitch is to use the Central Switch Management feature in DrayTek routers. This provides an easy way to manage and configure VLANs in VigorSwitches. Instead of logging into each switch and working through the configuration pages, you can log into the router and centrally configure and deploy the switches in your network from there. You can also monitor the switch and LAN client statuses, as well as perform maintenance tasks, and it also allows easy deployment. I'll go through the same VLAN setup example we just did, but this time I'll use the router Central Switch Management to configure the VLANs in the VigorSwitch. To begin, we need to have the VLANs configured in the router, so we go to LAN VLAN. Here we have port P5 as the trunk port, handling VLAN IDs 100, 200 and 300. Also, under General Setup, enable interLAN routing if needed. Next, down under Central Management External Devices, enable External Device Auto Discovery so the router can detect the switch. Once the switch is discovered, go to the Central Management Switch Status page. When the Add New prompt appears under the Add Device, click it to add it to the management page. Once completed, click on the switch name, then go to the VLAN tab and select which VLANs belong to each switch port. First, let's remove VLAN 0 from all ports. Then for VLAN 100, select ports 2 to 8. You may have noticed that I missed port 2 for VLAN 100 in the first example. That was just because I had the PC connected to that port. I later moved it to port 28, but then didn't show adding port 2 to the VLAN later. Never mind, this time I'll include port 2. VLAN 200 is ports 9 to 16, and VLAN 300 is ports 17 to 24. Then click on Save to save the settings. Then click on Send to Device to upload the configuration to the switch. And done. To check that the settings have been saved to the switch, we'll log into that. Go to the Configuration Port Setup menu. And in the VLAN tab, we can see the ports have been set up in access mode and with the required VLANs. Back to the router under the Central Management Switch Status. If we click on the Switch Hierarchy tab, we can see it in a graphical format. And under the Detailed Info tab, we can see some additional information. And we've come to the end of this webinar. We looked at why we need VLANs in a switch and the different types of VLANs that are available in DrayTek VigorSwitches. These included port-based, tag-based, voice and surveillance VLANs, MAC-based VLANs, and protocol-based VLANs. We also looked at the different interface VLAN modes. Finally, we went through a couple of VLAN configuration examples where we first configured the VLANs directly within the VigorSwitch menu and then carried out the same exercise using the router central switch management, which simplified the configuration process. Okay, that's all for now, but please stay tuned. If you have any questions, we'll be available in the live chat on the right of your screen for the next 5 minutes. For more information about DrayTek products, please check out our website at www.draytek.com.au or send us an email to sales@draytek.com.au or give us a call on 02 9838 8899. Please like and subscribe below, and if you'd like a notification anytime we put up a new video, please select all from the subscribe drop-down menu as well. Thanks and bye for now.